That would make sense.
I did drink.
I had a box of markers up here.
I think it fell in the recycling bin because his garbage can is at the back of the classroom and his recycling bin's at the front.
Oh, I'm talking about me in the beginning. I had a big thing of markers that was like $30 worth.
I got those for Mr. Bartels my
Wait, you
sophomore
found them
year.
in there?
No, I bought them for him because I only had like one black marker.
There you go. That's why. Now's the time to do it, guys.
Can I go get my drink?
Thank you. Yes. I have presents for you. Does anybody ask so much that they don't have any of this stuff?
Wait, look at how weird.
You?
No, I'm just playing.
Wow.
Ooh, I love Cheez-Its.
Well, that's good.
I don't think Katie's ever gonna eat these.
Okay, stop cheaposing. That's a dead meat.
I'm a Corona man.
It was never good when it was a thing either.
He asked
It's
me.
the planking
No,
of
he didn't know that. He got him on
2018.
Snapchat. He logged him on Snapchat.
I hate how accurate that
And I was
is.
like,
Yeah.
ooh.
We already did 5 and 6.
Some of you guys might already have this. If you want, you can use that as a practice roll for the quiz next
I
week.
recycle it.
Or you can recycle it. I don't care. I printed it all at once because we've had so many people gone, right? And mixing and matching just was not worth my time. So, sorry trees. But you can use it as like a study guide if you want to try it.
I'm a lucky boy.
Okay, no, sit down.
No.
I'm glad you're having a
No.
good time and feeling good. But you're
I don't have
happy.
that good. I don't want to do that.
Math class.
It's my birthday. I don't want to do anything.
No happiness in math class. You know
How I
the rules.
lost
Dude,
my
it's like
virginity
50
to
people's
a thin baked
birthdays today. Have
cookie
you
with
noticed
pictures.
that?
Happy birthday to 50
Happy
people.
birthday.
I'm not even kidding. Like,
Alright, do the
everyone
math.
was born on this day. Like Anna Zabo, you, who?
Mackenzie Niece.
Yep, I see Mackenzie Nees.
All right, we're missing bare hands. Apparently his
My
bare hands
birthday's
got
on the
germ hands.
10th. Yay.
Where's Doleschlager? Oh, he's here. He's just gonna
Can
give
I
us
get another drink?
Yes, go.
Wasted.
Diana's gone on vacation. She's missing the plague. McKenna is gone because she's sick.
Get out
Macy is here.
of the plague.
Macy, your hair. It's like wild.
Mark, can I give my food?
Wow.
I want to go get my food. My county kid.
Right, no.
Oh, no.
You erased it.
Oh, what did I erase?
It's my birthday.
Oh, okay. Well, we're gonna leave that up until June 11th.
My birthday's on the 10th and no one gives a shit.
Right, well.
I turned 18 after graduation. That's kind of
I'm a
weird.
nice person.
All right, yesterday, I believe we finished number 5, right? I believe we did.
Yeah.
Okay, I just gotta make sure because I know first hour and third hour are different. First hour more so than anybody. Yikes. So they'll be okay. We did 6.
You already gave me.
I want to look at. I know I did. I don't know who's got what because so many people are sick, so I double printed it. I do have new stuff for you. Let's look at number 7 today. Okay, and then we're gonna go and do number 4. Okay, for those of you that need a refresher on what we're doing. 7's not an easy problem, but it is intermediate. 4 is kind of hardcore. Okay.
Natalie can't even do a normal one.
All right, well, we're going to use this as practice to get you back up to speed, okay? So, we know that AC and BC are congruent. So, right off the bat, I'm going to write this. And I think alarm bells should be going off in most of your heads.
Wait, Zayden, what are you doing?
Oh, wow.
Are you joining us?
Why do we have a legend?
Not exactly. Zayden.
Yeah. Wait, Zayden's selling stuff there?
The school still hasn't gave me my number.
I know.
Mr. Bielma won't respond to my email.
CD and AB.
Let me throw it at you.
I only thought it's feeling it once. Alright. Yeah.
Bye, Zayden.
Bye, Zayden.
So that's that stuff. Now, what we're going to prove is that A, E, B, C, A, F, and B, D are related somehow, right? In this case, we want multiplication. What we're going to get is division because of proportionality, right? And then we're going to move stuff around and make multiplication.
Nice.
7?
Wait, what
Page
was the
6?
present?
What?
What was the present? Oh. Wow. You said you had
All right.
presents for us.
Oh, it was this. Did you get it?
Yep.
Okay. Great. All right, so. Man, 4th hour has a distinct vibe. All right. We know this stuff, okay? And we're going to prove that AE and BC and AF and BD are related. What's going to happen is we're going to get proportionality because of similar triangles. Remember the division thing? It's going to look something like this, right? And then we're going to move things around with multiplication to get it to look like that, okay? That's what we're going to be doing. So what does this mean? AE and BC we're interested in. AE is this segment. BC is this. Okay? AF is this, and BD is this. Okay, so what triangles do those belong to? If you can figure it out, then you can figure out which ones you need to zero in on. If you can't, because you're like Triangle City here, right? That's fine. Let's try to figure out what they're talking about. AE is this. Now, AE belongs to one triangle and one triangle only. Just this big triangle here, right? Does everybody see that? AE belongs to only one triangle. It also belongs to this kite-looking thing, right? But it belongs to this. Are we cool? So that triangle is one we're interested in. We also want BC. BC is a part of this triangle. Now that belongs to both the big triangle and this right triangle here, right? So it's going to be one of those two that we want. AF, again, belongs to that one triangle only, right? So we definitely want to talk about this triangle, right? And we also want BD. Okay, check it out. BD belongs to this triangle only, right? So we want BD and we want BC. So the two triangles we want to prove similar are this triangle and this triangle. Okay? That's what we want. I figured that out from here. Those are the segments we need. Now, pretend you don't see that. Okay? Pretend you're like, this is Triangle City, I have no idea. Here's what we can do. Why do I know that I can't prove this big triangle similar to, say, this triangle right here? Why do I know I'll never be able to do that? Recall from yesterday. Similar triangles have congruent angles, and they have proportional sides, right? Katie, what do you think?
Because like the part that's sticking out. Oh
This-
wait, wrong. Yeah.
Yep, this triangle and then this triangle. Does everybody see that? I'm talking about this one, okay? And I'm talking about this one. So biggest here, and then the biggest you can see there. Why do I know that this triangle and this triangle will never be similar?
Because it's half of it.
Not necessarily, but I like the thought. How do I know that this one and this one will never be similar?
Transversal line.
The line?
Yeah. No, that's the E.
The E.
The line E. I don't know, dude. Yeah.
Not about the line. Here, maybe we should do this first. What do you see right off the bat? If you did well on the last quiz, you should be able to see it. What's the thing? We have an isosceles triangle, right? So let's talk about that first, and we'll come back to that question, okay? So by isosceles triangle theorem, I know that since these sides are congruent on the big triangle, this is an isosceles triangle, and then the opposite angle should be congruent, right? Here's this side. Let's find its opposite angle, A, right? Again, focusing on the big triangle here. This side goes with this opposite angle, B. Not F, but B, right? Because that's not part of the triangle, that is. So these angles are congruent. So I'm going to write that. I can call it angle A, and I can call that, I can't call that angle B though, right? Angle A is the only angle A. I can't call this B because look, there's two angle B's. The left side and the right side, right? So I need to call it by its three-letter name. What three-letter name will I use for that angle? ABC, sure. You could also call it CBA, right? Remember, B has to be the middle because it's the vertex of the angle, right? So we call it A, B, C, or CBA. We just can't call it B because there's two angle B's, right? You gotta be specific. Only one angle A over here, though. All right, same question as before. How do we know that we can never prove this triangle, right here, and this big triangle similar? Remember, to prove similarity, we need two angles similar, two proportional sides with an angle in between, or all three proportional sides. Why can't we do this and that? How do we know that's never going to happen? This one and that one. Yeah. No, I do not. You may. Unless I can prove that that's a 90-degree angle, there's no way this one can be the same as that, right? Because that's a right triangle. And this one, as far as we know, isn't, right? All of the angles in similar triangles should match up, right? It only takes two to make sure they're similar, right? But all the angles should be the same, right? At the end of the day. We get the third one for free. That's why we only have to do two angles. So unless we can prove this and that's a right triangle, there's no way they can be similar, right? Now, I don't know how to prove that 90 degrees. Maybe it is, but I can't prove it, right? So I'm not going to match those two up. So if you can't tell that we wanted this one and this one from looking at those, at least you know we don't want this and one of these, or this and one of these, because that's a right triangle, or this and one of these, right? We can't prove that with right angles. So you can kind of do process of elimination to figure this out. Again, we want this one because it has AE in it, and it's the only triangle with AE in it. And it also has AF in it, and it's the only triangle with AF, right? BC, well, that belongs to the big triangle, right? But notice the big triangle, we don't know if it's a right triangle or not, so we're not interested in that. So what else does BC belong to? This guy, right? And if you notice, BD is also on this guy. So we want to prove this triangle and this triangle similar, okay? Those are the two we want to zero in on. So how can I prove this triangle and this triangle similar? Remember the things we need, right? This one, right here. And this one. BC. We need two matching angles, two proportional sides and an angle in between, or three proportional sides. I'll tell you right now, we do not have enough information about sides to do it right now, right? So do you see two matching angles between this triangle and this triangle?
Yeah.
Yep. They both have a right angle and a blue angle, right? Right angle and a blue angle. So by AA, those triangles are similar, okay? We can't prove congruent, that's fine. We'll settle for similarity. I, angle, angle, similarity. Let's do the triangle that's laying on its side first. Triangle, I'm going to write in alphabetic order AEF. Don't write congruent because we don't know that, is similar to the other triangle. Now when I write AEF, right, for this guy, that locks me into what I have to write for the other one. This one right here is what I'm talking about. Notice that angle A here would go with angle what on this triangle? On this triangle, angle A would go with angle what? B. So A and B go together. E on this triangle would go with D. The two right angles go together. F, the unknown angle, would then go with what? C. So because those triangles are similar, I can say this. By CSP, well, remember that's like CCP but with similar triangles, right? We can match up stuff. So look, A and B go together, right? And they do, they're the same angle. E, this angle here, should go with D, they're the same angle. F should go with C. So that tells me angle F, whatever it is, will be the same as angle C up here. Again, I knew that this triangle is similar to this triangle, and C and F go together. I know that by CSP because F and C are in the same spot, right? Okay, so I'm going to write that. Angle, I can call that angle F because there's only one angle F over there, right? Congruent to, can I call that angle C?
Yeah.
No, I cannot, right? There's two angle C's. Actually, there's three. That one, and then the whole thing, right? So I'm going to call it B, C, D. You could also call it DCD. I try to do alphabetical when I can. Cool. So those triangles have the same angle there and there, and they're similar. So now we have them similar. We can also say not just that their angles are congruent, but remember, similar triangles have proportional sides. And that's what I'm really interested in, right, the sides. So let's write that. What sides are going to go together? Well, AE on this triangle, right, goes with what on the other?
BD.
BD. And it will relate the same way as EF does in the first triangle to DC. Second and third, right? Natalie, you with me on that?
Yeah.
Okay, cool. Which will relate the same way as everybody forgets about first and third. I think everybody does these two and these two, and then gets lost, but AF also goes together. The same way that BC does, right? Notice I started with the left side triangle on top, so I kept using the left side triangle on the top, okay? AE, EF, and AF all come from this triangle, right? Make sure you're consistent, right? Now, do I know how they relate? Like, are they double of each other? Are they triple of? No, I don't. I don't have enough information to figure that out. But I know they do relate. So whatever it is, it's going to be the same for all its sides, right? If I have two triangles that are similar, it should be the same relationship for all of them. 3 to 6 is double, 4 to 8 is double, 5 to 10 is double, right? If we get something where if this was a 12, then they would not be similar, right? Because 3 to 6 is double, 4 to 8 is double, 5 to 12 is not double, right? So they would not be similar. So we know all those sides are going to relate by some number. Triple, double, half, I don't know. Right? But it's going to be the same for all of them because they're similar. Right? Triangles are similar. Now, what am I interested in? I'm interested in AE and BC. AE and BC are here and here, right? And I'm also interested in AF and BD. So I don't care about this middle guy, right? So what I'm going to do is I'm going to write that AE over BD equals AF over BC. I'm just going to focus on that, okay? Now, I want to get rid of division and make multiplication. Guys, algebra we do for a year, sometimes 2 years, depending on what you do with 7th and 8th grade math, 8th grade freshman math, right? And really, all it boils down to is two things. One, addition, subtraction, multiplication, division. How do I cancel, right? How do I do addition? I subtract. How do I do division? I multiply. And we spend like a semester on that, okay? That same question. I've got a +2. How do I do it? -2. I've got a +3. How do I do it? I don't know. Guys, it's -3. Oh, okay, right? That's algebra. That's my 7th hour class right now. The other semester you spend on y equals mx plus b and no one remembers that, right? That's the two things you had to learn. You had 2 years to do it. I don't understand why algebra is so complicated that it is. I wish you guys had me for algebra. It's really that simple. My algebra class right now, 7th hour, is doing sort of algebra 2 stuff because we've kind of run out of things to do. Again, you have those two things to do all year. Eventually they catch on. So, why did I say that? I want to get rid of BD being divided, right? I don't want to divide by BD. I want it to be multiplied on the other side. So how do I get rid of dividing by BD? Pop quiz, how do I get rid of division? I multiply. Not just multiply, but I multiply by what I'm trying to get rid of. So I'm going to multiply this side by BD. Now, if you're prepared for this, I'll do before and after. Right? Gross, right? ASMR, right? Do I have willing participants?
Are you gonna hit?
Mesa and you.
Make me more
All
uncomfortable
right.
than my
It's
own
mostly dry now. All right. So everybody knows I do this in algebra class. I don't know if you've done it in here, right? But if you do it to one side, it's child abuse. This is undebatable. You go to jail. But if you do it to both sides, it's algebra, right? So if we multiply one side by BD, we have to do it to the other side. This is a legal defense in court. I can attest to this.
Wait, that's why
I wasn't
not in
abusing my
jail.
child. I was doing algebra. There were 2 of them. Oh, okay.
That's
Right.
why Dad's not in jail.
Yep, there you go. All right, so that's a joke. I'm sorry. Okay, so now we know that we get rid of division by multiplying, right? The question is why? Why? Here's the idea. What we're really doing here, remember fractions are just division. So we're saying AE divided by BD. You can do multiplication and division in any order that you want. So I have all this stuff over here, right? I'm supposed to multiply by BD, I'm supposed to divide by BD, I'm supposed to, right, all kinds of stuff, right? So instead of doing this first, which I don't know what that is, I would say, look, I'll multiply by BD and divide by BD first. So what's BD divided by BD? Anything divided by itself is 1. Right? 3 divided by 3 is 1, 5 divided by 5 is 1, pi divided by pi is 1, right? So anything divided by itself is 1. So why do these cancel? Because they become 1. And anybody knows that 1 times AE is AE. 1 times anything is itself, right? So those become 1, because BD divided by BD is 1. And then I do multiplication. 1 times AE. AE. That's why they cancel. We need to get rid of cancel culture for lots of reasons, but mainly because of this. When I cancel division and multiplication, it becomes 1, right? But when I cancel addition and subtraction, what happens? What's 2? Well, how do I undo a plus 2? I subtract 2. Why do those cancel, and what do they become? Well, 2 minus 2 is what's happening there. That's 0. Notice this does not become 0, because if it did, we'd have 0 times a, and we get 0. Right? It becomes 1. So when we use the word cancel all the time, oh my god, kids have no idea why it does. It just, because, right? What's happening is this becomes 1, and 1 times a is 8. It goes away. It cancels, right? Over here, it's not going to cancel, because we have something divided by something else times something else, right? That's just going to be a thing. Now, remember, division is what's going on here. For fractions, division happens on the bottom, right? We're dividing by BC, right? And multiplication is what's happening on top, right? Like we had here. So when I write this, where's BD going to go? I'm timesing by BD. Is it going to go on the top or the bottom? It's going on the top. Multiplication on top, division on the bottom. That's it. I mean, of course, right? When you understand that principle, like, duh, of course it's weird looking, but that's it. If you had 3/5 times 2, the answer would be 3 times 2 divided by 5, which then you would say is 6 over 5, right? Yeah, you could put a 1 under the 2 and then multiply all that, but like, why? Multiplication happens on top, division happens on the bottom. I'll do the multiplication first, thank you, and then I'll divide. What's 6 divided by 5? 6/5. We spend 2 years doing this. I did not, but I think. All right. So great. We have AF and BD on the same side, which is what we wanted, multiplying. Now we got to get rid of divides by BC. Okay, algebra students, how do we get rid of divides by BC?
Multiply.
By BC to both sides. Somebody explain to me why BC divided by BC cancels. Anything divided by itself is 1. So we're now timesing by 1, right? And 1 times anything is itself, right? So AF times BD is what we get. And over here, BC times AE is this. Now, we almost have what we want. Notice AF and BD are in the right order, but at the top they have AE times BC. Why am I allowed to switch these? Why? Somebody explain. Give me an example. Why can I?
2 times 2 is the same as 2 times 3.
Yeah, 2 times 3 is the same thing as 3 times 2, right? Commutative property is what that is, but yeah, we're allowed to switch those. That's totally fine. We don't need to justify that. We're going to assume we all took algebra class with me. All right, there we go. Because you did, just now, today. You learned all of algebra in a nutshell. Except for the y equals mx plus b thing, okay? But that's super easy too. We can spend all the other days in the field about that. Yep, that's literally 2 things you do in algebra. That's literally it. And you spend 1 or 2 years doing it. Hey, we speak no evil unless it's about me. All right, I'm going to back up and go over this again. Here's what we did. We said Isosceles Triangle theorem, those 2 angles must be the same, right? These 2 sides are the same, those 2 angles must be. So that's an isosceles triangle. We said by angle similarity, this triangle is similar to this triangle. Because look, this triangle has a right angle and a blue angle. And this triangle has a right angle and a blue angle. So they're similar. Lots of other triangles are similar in this too, right? But we only cared about those 2 because those have the parts we need. We said just for funsies that those 2 angles were the same. Because they are. Because C and F, right? But we also got AE and BD, EF and DC, and AF and BC together, which is what we really were interested in, right? To actually solve the problem. Again, lots of things are true, but not everything's helpful. Like for instance, turtles can breathe out of their butts. True thing, but it's not going to help you on this proof. Yeah.
I get talk out of my ass, but no one gives me
Is that
compliments.
C is equal or 0 to F? Do you mean like the like right side of the line?
Let me say it. Say it again. Say it again.
When you say that like angle C is converted to angle F, do you mean like just the right side of the line that you colored?
Yes, and so see that is confusing, right? When I say angle C, because we don't know which angle C. I knew it was this angle because if you look, angle F can be written as angle AFE. AFE should be the same as BCD. BCD, right? Again, we're talking about those specific triangles, so that angle C. I can't call it angle C. I have to use a three-letter name, right?
Yeah.
This one I can just use one.
Okay.
Good question. All right, so now that I have their parts, I pick which ones I want, and I do math to get it to look like this, right? That's it. You feel okay? All right.
I can get my SIM card with this.
Here we go.
What's this?
5. It's the thing that makes your phone slow. 4. 4 is what we're
I
going to
heard
do.
y'all have one of those for and they could fit.
Or
and I
would give
passed
you
on
mental
it.
emotional pain.
All right, buckle up. Here we go.
Oh shit.
It's time.
Let's get down to
To
business.
defeat the Huns. D is the midpoint of AC, dark side of the moon.
I don't have that.
You don't have 4 from the original packet?
Oh, hecky heck.
Not the thing I gave you today. This is an extension upon that.
It's on the back of 3.
I used to do that all the time. We're on problem number 25. It's the one after 27 before 26.
Can I go get a credit card?
Yeah, that was my sandwich here.
Nice office.
Me
Not
with you.
What the hell? Yeah.
E is the midpoint of BC. We don't know that these are the same because we know these halves are the same, right? But it could be 3 and 3 and 4 and 4. Does that make
Why
sense?
did you check me really bad?
He is the
Sorry.
midpoint of AC.
Not forgiven.
Can I use a pretty color?
Never
What
forgive
color do you
someone.
want?
Purple.
These are all. These are for you.
I used to have a purple
Yo,
bedroom.
can you just throw something at me? I don't care what it is. Just throw
Purple.
something at me.
This purple's the
Like the
prettiest
right word?
purple in the world.
No, I don't even
No,
care.
I don't have
Just
time for
throw
that. All right.
something at me.
So, they give us this. So all we know is
Where's
that
the
D and
same
E are the
part?
midpoints of their sides.
Throw the same point
No,
at
don't
me.
do that. Evan did that earlier in his
never
row.
do that.
Big brain.
Evan did it?
Yep. Evan Scott. And it broke in half. Then he fixed it, sort of, which is good because that's
I
an
told
expensive
him
statement, and I got
fourth grade
$70 in my bank
I
account.
told him that you-
I
Right.
told him he had gray
Yeah.
hair in like 4th grade and he got
Better
so
than
mad at me.
Yeah.
He stopped.
Don't forget your student loans.
All right, now that I've got you all back, all we know is that we have some generic triangle, right? And we know that we've connected the midpoint to a vertex. And then we connected the other midpoint, shut up, to another vertex. So this will be true, whatever this means, will be true for any triangle. So here's a weird triangle, right? If I connect the midpoint of one side to a vertex and connect the midpoint of this side to a vertex, where they intersect will always produce this result. What does that mean? Any triangle, right? This isn't isosceles, it's not anything special, it's just a triangle, okay? BF and DF are related. Check this out. BF and DF are related. The same way that AF and EF are. So when we intersect those two things, right? They are related. And we know how they relate. It's going to be by double, meaning that this is always going to be double that. So if this is 4, that would be 2. And if this was 8, that would be 4. This is true for any triangle. This is an actually useful theorem, right? You have two things like that, and you see those midpoints. Oh, right away, I know that's double of that, that's double of that. Not only that, right? But it would also work for this line going to a midpoint. They'd all intersect at one point. We call that point the centroid. It's the center of the median. Medians are lines that are drawn from a vertex to a midpoint. Median, middle, right? And where they intersect will always be one point, no matter what triangle we're talking about. And that point will be the centroid, the center of mass, meaning the balance point for that triangle. There are lots of different centers in a triangle. One of them is the mass balance point, and that's this guy. And it will always cut the line into 1/3 versus 2/3, 2 versus 1. So that's double this. Okay. That's what we're going to prove. Later we can just use that theorem, but right now we're working on proving it. We probably won't even use it until next semester, but we're going to prove it right now. Okay. Actually, we'll use it 2 weeks from now. Maybe a week from now. 2 weeks. Okay, cool. So, we want to prove BF and DF the same. So if you look, BF and DF. Well, BF and DF, BF belongs to two triangles, this one and this one, right? Okay. And DF belongs to these two. So we haven't really narrowed down which two triangles we want yet. AF and FE. AF and FE. Well, AF and FE belong to these two, right? So which ones do we want? We want either of these two, either of these two, either of these two, and either of these two. The overlap here is these guys. Those are the ones we want. They both have BF and AF and DF and FE. Cool. So these two triangles are going to prove similar. Those are the ones I want. So how are we going to do that? We have no information about either of these triangles right now. None. So how are we going to get some? Yeah. Here's what we're going to do. I'm going to get this triangle and this triangle similar first. They're not the ones I want, but it's what I have to go with for now. Lots of you guys are doing that in your current relationships. So you should understand this. Notice that angle C is shared by the top triangle and the whole triangle. Remember that? Right? That's a super common thing. Why I'm going to do this is so I can get these bottoms to match. And notice these bottoms are also the bottom of this and the bottom of that triangle. Right? So angle C is shared by shared angle. Again, lots of true stuff to write, but not all of it's going to be helpful. For now, we're going to learn what looks helpful. Angle C is congruent to angle C. So now I can say the triangles are similar. Here's how I'm going to do it. We can say angle, angle, right? We can also do side, angle, side similarity and side, side, side similarity. Those are the ones we have. I don't have two matching angles here. I have one, right? So I'm not going to use that. But I do have two proportional sides with an angle in between that matches, right? Check it out. This side here is half this side, right? This is half of that. So this triangle side is half of the big triangle side. Isn't this also half of whatever this is? So both of these sides relate the same way, by half, right? So they are proportional. So I have two proportional sides, both by a half, right? And an angle that's congruent in between. So I can use side, angle, side similarity. Now, have I talked about the sides at all over here? No. So I need to talk about it. I have the angle. I need to talk about two sides. So what I'm going to do is I'm going to say that CD on the small triangle relates to what on the big triangle? CD relates to what side on the big triangle? What side? CD relates to, don't be afraid, you know this.
DA.
It does relate to DA, but the way we're talking about is small triangle versus big triangle, right? DA, yeah, see what I'm saying? CA or AC. I'm going to write AC because it's alphabetical. When I can, I do. That's just, wouldn't be wrong. Now, it's going to relate the same way as what on the small triangle does with the big triangle. What other sides?
CE and CB.
CE, and I'll write BC because again, alphabetical. That's just my thing, not your thing. Okay, it's fine. Now, not only do I know they relate the same way, but I know how they relate. This is half of this, right? Guaranteed. Now you might be saying, how do I know that's 1 and that's 2? Right? I don't. But I know if that's 3, this is going to be what?
6.
And if that's 5, that's going to be?
10.
So if I know it's 3, I get 6. And if I know it's 5, the other side is 10. And if I know it's 1, the other side is 2. Don't all those reduce to a half? So no matter what they actually are, at the end of the day, they're going to reduce to a half, right? It could be pi and double pi, right? It's going to be a half.
Gone.
So all of those are related by half, right? CD is half of AC. If you flipped it and went big to small, remember I went small to big, you would have gotten that AC is double CD, right? Flipped 2 over 1 flips. So I went from small to big, so I'm saying that CD is half of AC. Cool. You cool with that? Awesome. Now, what we're going to say now, since we have that these triangles are similar by SAS similarity, triangle, top triangle is CDE, the bottom triangle we just proved similar, the big triangle, we got to match those up. So C on the top triangle, what is it going to go with on the big triangle? C, angle C on the top triangle is going to go with what angle on the bottom, the big triangle?
CAB.
Also C, right? D is made up of the red side and the unknown side, right? So if we go to the proportional red side and the big guy, it's going to go with angle A, right? And then E is made up of the blue side and the unknown side. So proportional blue and proportional unknown, that's angle B. Does everybody see how I got those? Red with proportional red and the unknown, right? So that's A and D go together. Blue with unknown, proportional blue, proportional unknown, B. Okay? So those go together. They're similar by side, angle, side, similar. Now that we have that, we can use CSP, right? The CCP of similar triangles. CSP to get a lot of information. Here's the information I'm interested in. 2 things, okay? I could get a lot, but I'm only going to focus on 2. First off, by CSP, corresponding similar parts, because I've proven them similar, right? I can say that angle D is the same as angle A. How do I know that? Well, if you look, D and A go together, right? D in the small triangle is going to go with A in the big triangle, the whole thing, right? Because that's A in the big triangle. So I'm going to write that. Angle D, now I can't write angle D, I've got 3 angle D's, right? So I got to call it by its proper name, CDE. And if you look, doesn't CDE, isn't it first, second, third here? So without even looking at my diagram, since that's first, second, third, I know this should be first, second, third, angle CAB. Is the angle I marked in my diagram CAB? Oh yeah, it is, right? So they go together. CDE and CAB go together. Now, could I do the same thing to the other side? Yes, right? But I'm not going to, because I don't need it, okay? Will it be useful? Sure, but I don't need it. For instance, these are vertical angles, but I don't care about that, right? Lots of true things, like turtles can breathe out of their butts, right? But it's not going to be useful, so we're going to leave it. You'll get used to knowing what's useful and what isn't, okay? These 2 are going to be useful. I'm also going to say that since CD and AC are the same, so I'm going to write what I wrote again, the same as CE over BC. That's 2 of the sides matching up, right? What's the third side that's going to match up for the small triangle and the big triangle? What's the third side that must match? Must go together, not match, but go together. What side on this triangle will go with the side on this triangle? DE and AB are going to go together, right? They must. If these go together by double, these go together by double, then that should go together by double. So what is that DE, I'm going to do it in green, on the small triangle, will match up with AB on the little one. And not only do they match up, but I know how they match up, right? By half. So I'm going to write that too. That's all by CSP. If 2 of the sides are going to be similar, right, then the third side must be. Okay? And I know that because the triangles are similar, so all 3 sides should relate the same way, by a half. So if you want to mark that on your diagram, do this for DE. And then what I'm going to do is I'm going to put a dot in the middle of AB, and I'm going to call that M for midpoint. And I'm going to do that. Does that make sense? Right? That's how I can label that. So if you want, you can write let M be midpoint of AB, AM congruent to MB congruent to D. And that was all by CSP, right? I just got that from that. Does that make sense, right? I put a dot there so I could label it. Otherwise, it's like, how do I do that, right? So that's double this guy. Does that make sense? That's the way I would label that. All right. Check it out. We just got information about 2 of our sides for the 2 triangles we're interested in, right? So we've got some sides. That's good. That's awesome. Now I'm going to get some more information out of these angles. Because, like, why did I need that, right? Here's what this does. Remember when we did cap? It said that if I have 2 parallel lines, the line that cuts them is always a transversal, but when the lines are parallel, something magical happens. The corresponding angles will be congruent, right? Those 2 correspond. If the lines are parallel, then they're the same, right? That's cap, corresponding angles postulate, right? Turns out cap has a converse that is true. Every theorem has a converse, right? You just flip it around. But it's not always true forward and backwards. This one goes both ways. Kind of like Isosceles Triangle theorem is converse, right? So if I know that this angle and this angle are congruent, then by corresponding angles postulate converse, I know that what about these lines? They must be parallel. Does that make sense? So, look at the diagram. don't I have two lines cut by a transversal? And don't those two lines have corresponding angles that are congruent? Then what do I know about those two lines? They're parallel. So I'm going to mark that. I'm going to say by cap converse DE is parallel to AB. All right. So, why? Why is that useful? But why, right? Ryan Reynolds taking off the surgical mask, right? No, you ever seen that meme or that movie?
But
Yeah.
why?
But why? Exactly, there you go. Right, so, I know, check it out, if these lines are parallel, extend those parallel lines, why not? Right, we're not going to write it down, but do it so you can see it better. Don't you see that this line right here is a transversal, right? So check it out. If those two lines are parallel, this angle right here will be congruent to this angle down here. Don't write that, don't write that, don't write that. Look, don't write this. I'm going to show you a shortcut. These two are the same by cap. Do you see that? This angle and this angle right here, right? Now don't write that. Remember alternate interior angles, right? Check it out. What we do here to get this angle is we say, look, cap and then vertical, right? That's 2 steps. Alternate interior angles theorem is a shortcut for that. See how this is the interior between my parallels, right? Alternate sides of the transversal, right? Right side, left side, top side, bottom side. So by alternate interior angles theorem, I can just get that. I don't need to extend any of this. I've got alternate interior angles. We can use that as a shortcut. Could you say by cap and then vertical? Sure, right? But I'm going to save a lot of writing by just saying by alternate interior angles theorem, these two go together. So I'm going to write by alternate interior angles theorem. Can't call it angle D. I'm going to call it angle EDF, congruent to angle ABF. Yep. Cool. Now check it out. I've got another angle in my triangles now. If I can get one more, I've got angle, angle. Okay. I could also get angle, side angle if I can get these guys to match up. Turns out they do by the same thing, by alternate interior angles, right? So let's do that. By alternate interior angles, I know that this angle and this angle are congruent. This part of the orange, right? So by same thing, angle DEF congruent to angle BAF, BAF. You don't have to take BAF. And now I know, by angle, angle, right, that these two triangles are similar. Right, we have 2 matching angles for both. I have a side in between, but notice I don't have angle, side angle over here, right? And that's because double angle kind of takes care of it, right? We overachieve. But we're actually going to use those sides in a second. This is just the first half. So now we know those triangles are similar by angle, angle similarity, right? You can see why when I threw first hour into this first off the bat yesterday, it did not go well. So I'm going to write triangle DEF for the top triangle. Similar to, let's look at the bottom triangle. So D in the top triangle goes with what angle in the bottom triangle? B. E in the top triangle goes with what angle in the bottom triangle? A, as in A. And then F must go with what? F. By vertical, they would be the same, right? Or just by the remaining angle. So BAF. BAF. It's BAF time. So now we've proven this and this similar. Ooh, that's cool. I just made that up. That's my sign for those triangles are similar. Isn't that cool? I just made that up. Now I know they're similar. It's like a cat eye type of deal. Makeup artist. They call me A Squiggle. I make you look good.
Here's your thing.
That's right. All right. Now check it out. If the triangles are similar, their parts should be, their sides should be proportional, right? So I'm going to say that these parts go together, right? How much time we got left? 11:30? We're out. Okay. Tomorrow we're going to finish this up. The last thing is, now that I know they're similar, their parts are proportional, and I get this, and I'm done. Yeah! Yeah. Good job. Killing it.
Appreciate it.
I always do.
I don't want to take them back to the
Yeah,
stairs.
problem. Like, you gave me just,
I didn't give you the whole thing.
no.
Go away.
You gave me just like the blank. I couldn't do it at all.
I know. That's why I'm taking the quiz next week. Okay. We're just learning the new idea now. We're going to cement it next week.
I want to let you know that I turned in both of my.
Yes, I saw that. That is good. I will get it done. I'll have to do more grading this weekend. I've been doing grading every night. I just didn't do it last night because Landry looked at me and said, you need to take your own advice, because she was here until 5, and I was like, go home, don't do any math. You need to
This
charge
is
your grade.
train the hog words.
You do that. And I'm like, okay, and so I left it here. I'm sorry. So if you hate me, you have to hate Landry. No one can hate Landry.
You have
So you know how I'm going to
you guys.
I do, version 2. I
term 1 and then term 2, and then I don't get off. I don't have a summer break.
do. For not having fun,
Between
whatever.
my first and second year, I don't have a summer